Now we want to talk about why do things look weightless, and I want you to think about what's it like when you get into an elevator and the elevator starts to drop. Does it? You should notice that you feel like you weigh less. You can actually take a bathroom scale into an elevator. You might look a little stupid doing it, but taking a bathroom scale into an elevator, stand on the scale, and then notice what happens to your weight as the elevator is dropping. And you will notice that your weight for a short period of time decreases. Now, once the elevator starts moving at a constant speed, then you notice that your weight comes back to normal. Also, get into an elevator, stand on a scale, and have the elevator go up, and you will notice that for a short period of time, you weigh more than what you normally do. So, imagine what would happen if you were in the elevator and somebody cut the string. Okay, they cut the cable holding up the elevator so that the elevator is in free fall. And then also at the same time, let's pretend that you've got a ball and you hold the ball out over here and then you let go of the ball at the same time that somebody cuts the elevator thing. So what you would notice is that ball would be suspended in front of your eyes as long as you were both falling at the same rate, and then when you got to the bottom of the elevator shaft, that's when you would suddenly feel the effects of gravity. So you're feeling the effects of gravity as the elevator is falling. Gravity's there, but it's just that you don't notice those effects. So that when you're in an elevator and it's dropping at the acceleration due to gravity, which was, you should know that that is g, and that's equal to 9.81 meters per second squared. That's called the acceleration due to gravity. So if the elevator was dropping at this acceleration, then you would be weightless. You would actually be floating around inside of that elevator until you came to the bottom of the elevator shaft. And then you would definitely know that gravity was there all the time. Now, also notice that you would be weightless if you were deep, deep, deep in outer space. So if you are away from any other planets, you would be floating around in outer space. And so that would be weightlessness. So notice that when you are falling at the acceleration due to gravity, you're going to be weightless. So the problem then is, how do the people up in the International Space Station, they're weightless because they're falling towards the Earth. That's why they look like they're weightless. But they're really not. There's a lot of gravity up there. So if you look at the notes down there at the bottom, it says that the International Space Station is about 409 kilometers above the Earth's surface, but the acceleration due to gravity is still about 80 some odd percent of what it is on the surface of the Earth. So even up there where the International Space Station is at, there's a lot of gravity up there. The reason why they're weightless is because they're falling towards the Earth in the same way that this elevator is falling towards the Earth. Now that brings up another question though. Why don't they crash into the Earth? So that's the second picture. In the second picture, here's the International Space Station, and if it wasn't moving sideways, it would crash into the Earth because of the gravity. but it's moving in this direction at the same time because it's in orbit around the Earth. So imagine that in the time that it takes an object to fall this distance over to here, the space station has orbited over to here. So do you see that it's the same distance that it was before? So as this thing orbits over to here, it did fall this distance, but the problem is now it's over here and it's got to start all over again. And so in the time it would take for this object to fall again this distance, then because the space station is orbiting in that direction, it would orbit over to here, and again it would be that same distance that it was over here. So it's been said that a object in orbit is falling around the planet. It's falling, but as long as the speed is sufficient, it never gets any closer to the surface of the Earth. Now, what happens if the speed is not fast enough? Well, then you have a decaying orbit, and eventually this object will crash into the Earth. Okay, so we'll come back to this later when we talk about circular orbital speeds and then what is escape speed. We'll talk more about this. Okay, so let's take a break, and when we come back, we're going to talk about the gravitational field.